Hello, this is Mr. Stansbury. I'm going to take you through the notes on area. Okay, at the end of this, you should be able to say, I can find the area of various shapes and figures. Okay, so first off, the area of a closed figure is the number of square units that it contains, or the number of square units that you can fit inside of it. For quick example, if you've got this here, let's say this is 3 centimeters by 2 centimeters. We break this into little groups of, let's see, there's 2 here and there's 3 this way. There's 1, 2, 3, 4, 5, 6. We have 6 square centimeter squares in there. Okay, so or the easy way is 3 centimeters by 2 centimeters. 3 times 2 is 6 centimeters squared. Okay. Some common area formulas. Rectangle is length times width. Hopefully you remember that one. Triangle, 1/2 base times height. Hopefully you remember that one too. Parallelogram is the length of the base times the height. A trapezium or trapezoid is you add the 2 bases together, A plus B. These are both called the bases. That's the parallel side. So you add the 2 parallel sides together, divide by 2. So you're taking the average of those 2 sides, multiply it by the height. So similar to the rectangle and the parallelogram. And then circle area is pi r squared. Okay. Again, these formulas here, I believe, will be given to you when you take your IB test. So let's try some of these out. Find to 3SF, 3 significant figures, the area of each of these 2 figures. So rectangle, we can tell it's a rectangle because it's got all right angles. So this is simply going to be 22, oops, let's do this in a different color, 22.1 meters times 79.3 meters. Right, so we've got 22.1 times 79.3. And that gives us 1752.53. So 1752.53 square meters. Now, this is not to 3 significant figures, so we have to take this to 3 significant figures. So first non-zero from the left is this one. So 1, 2, 3. There's our 3rd significant figure. That's where we have to round it to. The 2 tells the 5 to stay the same, so we go 1, 7, 5. We need to put a 0 in there to hold the place, otherwise it's wrong, right? Otherwise we'd have 175 square meters when it really should be 1,750 square meters. Okay, so that's our answer to 3 significant figures. Okay, area of a circle, area is pi r squared. Okay, so our area is going to be pi times our radius. We've got 5.13 for the diameter, so we got to take half of that. So let's do that here. We got 5.13 divided by 2. And we get 2.565. 2.565. In order to get an accurate answer, you want to save all your rounding for the end. So try to be as accurate as you can before that, because if you round too much, your answer will become inaccurate by the time you get to your final answer. Okay, so our area is simply going to be 2.565, and that's officially centimeters squared, right, times pi. So we already have the 2.565 in there, so we just need to multiply by pi, and we get 8.058. Let's do that, 8.058, right? 8.058. Okay, and this is centimeters squared. But again, we got to go to 3 significant figures. Start from the left, find the first non-zero. There's the first one, first significant figure, second significant figure, third significant figure. This 8 tells the 5 to get bigger, so it's 8.06 centimeters squared will be our area of that circle. Okay? All right. Last examples here. Calculate the shaded area. So we've got, we are trying to figure out what just the yellow piece of this here is. So a couple ways you can do it. You can try to figure out the area of the trapezoid here, because this It doesn't show it in here. I should have it in here, but these are all right angles. Okay, so I can't really see that. Let's try this in a different color. Okay, there we go. So these are all right angles. So that makes this a rectangle. Or what you could do is look at this as a trapezoid. So if we find this base, add this base to this base, divide by 2. Trapezoid area is base 1. What did they call it on there? Let's double check here. Just the top plus the bottom. So I'll do base 1 plus base 2 over 2 all times the height, right? So base 1, we can make that the top. That's 30. Base 2 is the bottom. Now, it doesn't specifically say, but since these two sides have to be the same since it's a rectangle, we've got the double lines here, double lines there. That means that these two are exactly the same. So that basically means that this side here is split exactly in half. So that's going to make this 30 divided by 2, which is 15. So this is 15 right here. So 30 plus 15 divided by 2. Take that whole thing and multiply by the height, which is 18. So let's just do that quick over here. So we've got 30 plus 15 is 45 divided by 2 gives us 22 and a half. And then we just multiply that by 18. Okay, and that gives us 405. So this is 405 square centimeters is the area of the shaded piece. Okay, now another way you could have done this is, let's just do it. We could have found the area of the rectangle and subtracted the area of the triangle, right? So let's do that really quick. Say, or we could have done area equals the rectangle minus the triangle. Okay, so in this case, the area of the rectangle is 30 times 18. Oops. 30 times 1, 8, minus the area of this triangle. And again, since we figured out that this is 15, this here also has to be 15. So that's going to be 1/2 of 15 times 18, right? So if you go through and figure that all out, we should get 405 centimeters squared, just like we did here. Let's just show it on the calculator just to make sure that we're all good. Okay, so we do 30 times 18. Let's just do equals. That's 540, and we're going to subtract 15 times 18 all divided by 2. So subtract 15 times 18. And then we're going to divide that whole thing by 2. And if we put it in like this, this is officially 15 times 18 divided by 2, which is the same thing as 15 times 18 all divided by 2. So we'll just leave that there. And look, we get 405, same answer. Okay? All right, let's see. Let's go to B. So we got to find the area of these 4 regions here. So on that, I'm thinking that our best bet is going to be find the area of the square and subtract the area of the circle. And that will leave just the yellow pieces there. All right? So again, I did not put my little right angles in there. But it's assumed that since this is a circle here, which kind of hard to tell, but it's supposed to be a circle, that all these sides would then have to all be the same. So these are 16 also. So the area of that square is going to be 16 times 16, or 16 squared, minus the area of the circle. And remember, the area of the circle is pi r squared, so minus pi times the radius of this circle is from here to there. So that's just going to be half of this distance. So 16 divided by 2 is going to give us that this is 8 millimeters times 8. We'll put our label on here at the end just to save ourselves a little bit of room. So put that in here. We've got 16 squared minus, and that's pi times 8 squared, not just pi times 8, minus pi times 8 squared. Okay, and we'll get 54.938. 54.9, is that what I said, 938? 54.938. Again, it doesn't specify, so I'm going to just go to 3 significant figures. That seems like a pretty reasonable answer for this one here. So area equals, I'm going to round, there's first, second, third significant figure. The 3 tells the 9 to stay the same, 54.9 millimeters, and this is area millimeters squared, right? Because we have, that's millimeters squared, that's millimeters squared. Okay, last one, shaded area. So really this whole thing here, this is all shaded. We want to figure out the area of this whole thing here. Okay, so I'm going to take that out just so it's easier to see. And away we go. So we could do this a couple different ways. We could cut this into, say, a rectangle here and a rectangle there, add them together. Or you could find the area of the big rectangle and subtract the 2 smaller rectangles. I'm thinking that adding these 2 rectangles together is probably going to be our easiest bet. So let's try that. So first off, we got to figure out what our missing pieces are here. So let's see, we've got that this is 7. All these with the double lines here are all going to be 7. So this is 7, this is 7, this is 7, and this is 7. Okay, so we have now enough to figure out what this is. This is going to be, let's do that down here, 7 meters times 12 meters is going to be what, 84 square meters. So that's this here, 84. And then to figure out this here, we have this 7 here, but we have to figure out what this base length is down here. That's going to be this 7 plus 7 plus 7. So that's going to be 21. So now we got to take 7 times 21. And let's just do that here. So 7 times 21 gives us 147. Square meters. So the total, this is 147 square meters. So the total would be, add those 2 up, right? And that gives us 231, oops, square meters is going to be our total area of this whole figure here. Okay? All right, that's all there is for the area notes. If you have any further questions, please feel free to ask in class. Thanks.